Alright, hello guys, welcome back to another video. So today we're going to be talking about section 2.6, more on inequalities and problem solving. So since this section is really long, I'm going to put this video into two parts. This one is going to be released today, and then the next part is going to be released tomorrow. And yeah, that's it for the intro. Let's get into actually solving. So we have our first example, which is 2/3 x minus 1/2 x, which is greater than 3/4. So we already have the x's on the left side and the numbers on the right side. Now we just have to simplify the left side in order to have a single fraction. So first thing we're going to do to simplify the left side is find an LCM. Our LCM is going to be 6. So we're going to have 4x minus 3x is greater than 3/4. And we're going to have x is greater than 18/4, which is 9/2. And we're going to write that in interval notation as 9/2, comma, infinity. Okay, so our next example, we have x/2 minus x minus 1/5, which is greater than or equal to x plus 2/10 minus 4. So in this one, I'm going to use a different method. I'm going to multiply both sides with 10 so that I can eliminate the denominator. And we're just going to simplify now. So 10 times x/2 is equal to 5x minus 10, or no, not 10, but 2 times x minus 1, which is greater than or equal to 10 times, or not 10 times, but x plus 2 minus 4. And then we're just going to simplify now. So we're going to get 5x minus 2x plus 2, which is greater than or equal to x minus 2. We're going to keep the numbers on the right side and then move the x's to the left. So we are going to get 5x minus 2x minus x, which is greater than or equal to minus 4. Or actually not minus 4, but minus 2 minus 2. And then we're going to simplify. So we get 2x is greater than or equal to minus 4. And then we're just going to divide both sides with 2 in order to get x is greater than or equal to -2. So we're going to write it as -2, comma, infinity. Okay, so our next example, we have 0.08x plus 0.09 times x plus 100, which is greater than or equal to 43. So we're going to simplify the left side first. We're going to use the distributive property to remove the parentheses. So we have 0.08x plus 0.09x 0.09x plus 9, which is greater than or equal to 43. Now we're going to move the 9 to the right side of the equation so that we have the x's on one side and the numbers on the other. So we're going to get 0.17x, which is greater than or equal to 43 minus 9, which is 34. And we're going to divide both sides with x. So we get x is greater than or equal to 34 over 0.17. Move the decimal place over 2 places, add 2 zeros. And we're going to get x is greater than or equal to 200. Since 17 times 2 is 34. And then we just add the 2 zeros at the end. Okay, and we're going to write it in interval notation as, let's see here, brackets 200, comma, infinity. Oh, if you want to learn how I do interval notation, click the info card at the top right, and it'll bring you to one of my videos, my previous video that has the interval notation in it. Okay, so now it's time to learn a little bit. So, in mathematics, when we use and or, we use them to form compound statements. When we use an and statement, that's called a conjunction. A conjunction is only true if all the components of the statement are true. So basically what that means is that whatever two equations you have, those two equations need to be true, and they also need to have an and in between them. So for example, we have 3 plus 4 is equal to 7, and negative 4 is less than negative 3. That is true. So the 3 plus 4 equals 7, and then the negative 4 is less than negative 3 is true. So, and then it also includes and, so it's a conjunction. It's a conjunction, and it is true. Now this one you have negative 3 is less than negative 2, which is true, and then you also have an and, which is important for a conjunction, and you have negative 6 is greater than negative 10, so it is true. Now the next two are going to be false. You can look through them. Hopefully you don't need to verify anything, because these are all quite simple problems. So just look through them. I'm gonna scroll down in a little bit. Okay, so I'll just quickly go over them anyway. So we have 6 is greater than 5, and negative 4 is less than negative 8. Negative 4 is not less than negative 8. Negative 4 is actually greater, that's why it's false. So we have negative 3 plus 2 is equal to 1, which is not true, and 5 plus 4 is equal to 9, which is true, therefore it is false. Now when we use or, that is called a disjunction. So basically what it is that when you use or, only one of the two things that you have in that statement have to be true. So like in this one, we have 0.14 is greater than 0.13, which is true. And then you have the or, and you have 0.235 is less than 0.237. This is obviously false. The right one is greater than the 0.235, and then that's why it is true, because it only needs one of the two equations to be right. So the next two are also true, but if you want a false one, I can make up a quick false one. So we have 34 is less than 6, and then we can just write that 2 times 3 is equal to like 7 or something like that, and that's going to be false since they are both false equations. So I'll keep it up there for a little bit, and then I'm going to erase it. Okay. So now let's move on to our example. So we have graph the solution set for the conjunction x is greater than negative 1 and x is less than 3. So first of all, we're going to draw a number line. 0, 1, 2, 3, 4, negative 1, negative 2. So we know that x is greater than negative 1. I'm going to do this in red. So x is greater than negative 1, and since it does not have a bar underneath the greater than or less than sign, it is a open circle or parentheses, and we know that it goes like that. And then x is less than 3 is like this, That is not a very accurate representation. There we go. X is less than 3 is like that. So when you're doing a conjunction, you want to look at these two, and then whatever's in between this much, the stuff that's shaded in black, that's in between the two solution sets for these two different equations, and that's going to be your answer. So whatever's in between, like in this, we have x is greater than 1, so the arrow is going that way, but in the when you're going x is less than 3, the arrow is going that way. So then this much intercepts, and then that is our solution set with the conjunction. And I think that is it for this part. If you liked the video, please be sure to give it a thumbs up, and make sure to subscribe in order so that you don't miss my next video. If you need help with this section or any other previous section, my emails will always be at the end of the video. Otherwise, I hope you have a great rest of your day, and yeah, thanks for watching.